All right, let me slide. Let me just kind of pick up where we left off, and then right there. Okay, the last thing I talked about was I showed the plot right there, and we talked about this G-text allows the placement that there. The grid is missing something here, and this instruction just says puts grid lines on the plot. You have to say grid on or grid off. That is missing that as part of the command. I sat there, and that was the last thing when I said it's time for a break. My brain didn't remember that right off that there. So that there, but you have to remember that. The last thing here is this G-text, and this G-text right there. Oh, right there. This G-text, and you can see where grid on. Now, unfortunately, we were I think this was the last thing after everybody was kind of leaving. We were commenting the fact that you can't see the grid there, but there is a grid there. And it might there. You know, on my computer here, I can see the grid right there, and that's with grid on. And then if I turn that to grid off, the grid is not there. So again, that there. Now, you could have multiple plots on the same plot right there. So let me, first off, let's just do a CLC here to clear the screen here. And I could do a x is already equal to that there, but let's just do it again. X is equal to bracket 0 colon 0.1 colon 2 times pi, close bracket, semicolon, right there. And I can say y is equal to sine x right there. And I can say z is equal to sine 2x right there. Right there. So now I've completed that there. So I can do a plot x comma y comma x comma z right there.
Z.
Z. Okay. So the brain and the fingers aren't cooperating right there. And what I see, you can get two plots on the same right there, and that's useful for multiple plots up that there. So again, you can show, you know, one of the things that this is useful for is showing here, right there. Right there it says 2x, I can say x plus pi divided by 4, right there. So again, that's showing a 90 degrees phase shift right there. And you can show a phase shift. Now, again, as mechanicals, you don't show phase shifts, but in the electrical world, we show phase shifts, and you know, all the time between RLC circuits that there you have phase shifts. So you can see how you can get two graphs with a 90 degrees. This one is lagging by 90 degrees right there. So it's fairly, you know, for plotting, it's one of these really ideal tools right there. And then the other thing we did was plot, and we can say x label, you know, x right there, y label, y right there. And what is the command for title? I can't remember the command for title, but we'll just use title. And 90 degree phase shift right there. And I need the apostrophe right there. And you can see the title is placed on that there. So I've got X and Y right there.
How about a Z?
Well, again, because I put the title, I should say this should say X and right there. You know, the label right there, and Z right there. But now, if you want X and Z to be separate, then what you would want to do here is, let me just say voltage here and time, and we will stick at the end of this here, and what I'm going to do here is put a dot 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 and bring that down to the next line. Right there. And then we can put what the other command that they're pull it up there. It's called gtext, and then text right there. So I can put gtext right there and across R, gtext across L, for example. I don't know if I did this right. And what it's looking for here is I'm going to say here, I'm going to put across R, and over here, right there. And it allows me to put the individual, so I'm using that gtext command in order to place on the graph where I want the labels to be. Right there. So again, the whole idea is if you wanted to do plots, then I can then do the Alt print screen. I think it's Alt print screen right there. Control print screen. No thanks, okay. And then I can bring up Word here. And there's my window there shown. Right there, so I can cut and paste it into Word documents relatively easy right there. So, you know, that's the whole idea of doing these graphs, is that we can easily cut and paste them into Word documents or spreadsheets or something like that. So as you're writing up assignments to pass out and you want graphs, it's very quick and easy with MatLab to come up with these graphs right there. Right there. So, all right. I think that's pretty much it on graphing commands. Again, we did the title, X label text, we did all those right there. Again, you said X and Z. The problem is we're using the same scale, so right there. Okay, this is one I'm going to go through and talk about. It may not be as much interest to you as it is to me, and that is solutions to simultaneous equations right there. So in the electrical world, our students probably spend a fourth of the time in their circuit analysis course, their first circuit analysis courses, learning how to solve systems of equations right there. And normally we teach Kirchhoff's voltage law, Kirchhoff's current law, and then students write the equations, and they come up with a series of equations right there. If my pen was working, let's see if I try again. I can just show you an example of where this is used in an electrical course right there. Let's say I have a circuit right here, 20 volts right there, a resistor, 10 ohm, another resistor, 20 ohms, another voltage source, 10 volts right here, another resistor, 6 ohms, another resistor, 8 ohms, another voltage, 12 volts right there, and and 15 volts right there. We'll say 8 right there. So this is a typical circuit I would give a student out there. And some of you have seen this. I see you shaking your head. You've seen this before, right? You probably don't remember how to solve it, right? 30 years ago, yeah. Yeah, well, I'm an electrical, so this is a common problem. So unfortunately, you hired an electrical to teach a class, so I'm going to use an electrical example. That there? So yeah, so I'm going to write a matrix for this, and my R matrix is going to be equal to And first off, I'm going to just simply say it's going to be equal to 30. And I'm going to show my loops 1, I1, I2, I3, right there. 30 minus 20 and 0, minus 20, 0, 26, 34, 34, minus 8, and 16, right there. That's my 1 voltage right there. And my V vector is equal to 20. Actually, no, it's not equal to 20. It's equal to 10, right there. Somebody remembers this, right? So I'm going out to 12, so it looks like this is going to be 2. And this is going out the negative out there, so it's going to be negative 3, right? Does that look about right? So those are my 2 matrices. And of course, Ohm's law says that V is equal to R divided by, or excuse me. Well, actually what I want is I is equal to V over R, right? And boy, and I'm just starting this hour and I'm already starting to disconnect my mouth and at there. And so again, the way we would write this matrix form, we would write this as I is equal to R to the minus 1 times V. That is the way we would do that right there. Because this is Ohm's law, using it, that there. When you write it in matrix form, you have to do it this way right there. So, or you could use his backslash notation. So again, I'm going to just use his example, but this is where this comes in right there. But again, what this is saying is that 30 I1 minus 20 I2 plus 0 I3 is equal to 10, right? Minus 20 I1 plus 34 I2, and again my handwriting is terrible there, minus 8 I3 is equal to 2, and 0 I1 minus 8 I2 plus 16 I3 is equal to negative 3. And so we got a system of 3 equations and 3 unknowns. I just stuck it in matrix form just because it's shorter right there. So with that said, and my pen actually worked for a while if I don't use it right there. With that said, he's got the solution right here. Now he uses the A/B, the backslash right there. So I use the A to the negative 1 times B right there. So either one of them works right there. So the solution that there, and the other day I did this in class like a week or 2 ago, and I could not get the matrix right to save my life, but I'm going to try. And what I'm going to do is I cheat right there, is I try to put them both on the screen at the same time, right there. So, in this case I'm going to call it R, and I personally like to use upper letters for matrices and lowercase for, for single variables, but you do it however you want. So R in this particular case is 6, 12, 4, semicolon. Now he puts commas in between. The commas are optional. You don't have to put the commas there. 7 minus 2, 3, semicolon. 2, 8 minus 9. Now I could tell looking at his matrix that this did not come from an electrical circuit, because electrical circuits, if you do them right, are always negative off the main diagonal, right there. So the main diagonal is always positive, and off the main diagonal, if you draw your loops clockwise, is always going to be negative. If you draw your loops clockwise, right there. That's the way I normally say to do it, right there. So there's our matrix right there, 6, 12, 4, 7 minus 2, 3, 2, 8, negative 9. And that's correct, right? So then we're going to put in the next one, and I call that B, that there, is equal to, bracket, 70, semicolon, 5, semicolon, 64, right there. And it's like this. Or you could say V is equal to, and if you're a lazy typist, right there, and you put the little apostrophe at the end, and the apostrophe at the end tells it transpose the matrix, do a transpose right there. So up and right there. So either one works right there. You can either put the semicolon between each of them, or you can leave the semicolon off and then just transpose the matrix at the end right there.
Why you put apostrophe?
Well, because what that does is that I'm just going to say I is equal to, or B is equal to, if I do it like this, 20, 30, 40, like this, that gives me a matrix 20, 40, or 30, 40. By putting the apostrophe, I transpose it right there. That does a transpose. So if I take, for example, well, let me just do a matrix here real quick. Right there. Let's just take a matrix here. Let's just call it A is equal to, and I'll just do it 1, 2, 3, 4 right there. So it's 1, 2, 3, 4 like that there. The first row and the second column. If I do A transpose, you notice that the rows and the columns are reversed. So here is 1, 2, and here it's 1, 2 this way. Here it's 3, 4, here it's 3, 4. I just transpose the matrix right there. So right there. So getting back to where we were at, I did the R matrix and I did the B matrix right there. So those are the R matrix. So my current matrix is going to be simply R raised to the minus 1 and if I find my key, raised to the negative 1. And again, you can put parentheses around this to make sure it's clear to you, because exponentials are the highest order of that there. The parentheses are not required right there. So times B, and there's my 3 values, and those agree with his, so I got that right this time.
If you put B first?
What's that?
If you put B first,
It won't work. No.
Oh, it won't work.
It'll give me an error, if I'm not mistaken. I've never done it that way, but we will try. Yeah. So, yeah, that doesn't work, because the problem is it's looking for 3 rows. The number, when you multiply matrices, the number of rows and the number of columns have to line up right there. So if you've got 3 rows, you need, if you got 3 columns, you need 3 rows right there. So in the second case right there. Now the way he did that, he just simply said that I is equal to R backslash B right there, and it comes up with the same answer. To me, it just makes more sense to use the V, the R to the negative 1, because that's what you're doing in matrix form. Because all you're doing in matrix form is you've got this matrix R, which is equal to this here. I'm not going to repeat R right there. And you've got this matrix I, this vector I, which is your unknowns right there. I1, I2, I3. That's what you want to solve for. And you've got another vector, B, which is equal to that. These two you know, right? Well, Ohm's law says that V is equal to IR, right? Right there. So what we're going to do is we're going to we need to solve for I. So what we're going to do is we're going to multiply, post multiply b times r to the negative 1. Well, again, I'm going to reverse this here. I'm going to say ri right there. Just simply, the order of multiplication doesn't make any difference. You have to do the 3 first anyway in order to get the multiplication to work out right there. So b is equal to ri. I multiply both times r to the minus 1, r to the minus 1, right there, minus 1, r to the minus 1, that there. These two cancel out, and I'm left with I is equal to r to the negative 1 times b in matrix form right there. So when you solve the problem in matrix form, you use that format. So that's why my brain still thinks r to the minus 1 that there. It's a short way of doing that there. So again, this problem makes a lot more sense to us electricals than it does the rest of the world, but it is something that there. And you do have systems of equations, right? That there. I know in fluid power it's a common thing that there. I haven't seen it in other places, and I'm sure chemical does as well. That there you have it there. But again, this is a easy solution using that there, for systems that there, and we'll see some more of that there. Okay. There. Okay, now we're going to enter the world of scripts, and this is where I'm going to kind of turn over some things that there. A script is a program that you store. I've already introduced that there. Type of file contains equivalent of typing all the commands one at a time into the command prompt window. You can run the file by typing its name right there. So we're going to be looking at script files right there, and script files are a MATLAB program, but don't think in terms of a program. I like the word script better right there, because you're just telling it to do the same commands you can do in the command window right there. So, right there. So, one of the first things you want to do is you can put comments in, and the comments are basically start with the % sign. It tells it to ignore everything right there. So x is equal to 2 plus 3. Right there. So this is a comment that there, and then it just comes back right there. So again, we can bring up the editor debugger that there. Now you have the option of running debug on that there, just like you do any other there. One thing I should mention is that when we're using MATLAB, this chair falls back too quickly that there. Kick back and put a headrest here and take my nap here, right? Right there. One thing about MATLAB is that it's an interpreted language. And for those non-computer people, an interpreted language means that the MATLAB software will go through and read one line at a time and execute your script as a script. It does one thing at a time. When I say a script, if you're a star in a movie, right there, I've actually played an extra in one movie one time when I was much, much younger. That they're probably better looking too. I was definitely thinner that there. But I was along with another 200 other military folks marching. But if you had a talking script, in other words, you say the lines one at a time. You execute them one at a time. A compiled language such as C means that the computer will compile that program into machine code, that when you run the program, it runs as fast as it can, because it's running the actual processor commands, of ones and zeros, as that there, and will also optimize the code for you. That there, if you do silly things and the compiler says that you don't need to have that line, I can replace it with something else, the compiler will rewrite your code for you, which in the embedded world can sometimes make our life interesting, because sometimes we put in silly things on purpose just to kill time. That there, but regardless, it's an interpreted language, which means that it's going to run much, much slower normally than a compiled language. That there, so if you have some code that's going to be a very large program and it's going to take a lot of time, you probably don't want to use MATLAB for programming that there. So That there. But again, we're looking at that there. So I'm going to, no, I got to get the right key here. Right there. So I'm going to just go ahead and bring, let me minimize that there. Let me bring this up here full time. So what we can do here is we can hit this little thing here, blank script right there. Right there. And we hit blank script, it brings up the editor in the editor mode right there. So we can start typing right there. This is my first MatLab program script right there. Not sure what I want this to do, but here goes. Yeah. So I mean, it's, you just put your normal comments there at the time that they're, normally a student would put in their assignment 1A. Standard hack, Professor Ibrahim. That there, I didn't spell that right, but again, that there, Ibrahim, whatever. I mean, again, you just put down Professor X Y that there, and you would just put the whatever you want that there. So that there, and then you would start writing your commands what you want this particular program to do. So, for example, I wanted to solve that particular circuit there. And again, I don't have the matrices in front of me, but if I wanted to write a script to solve a 3x3 a system of 3 equations, 3 unknowns, that there, I could simply say, and I have students do this, by the way, that there, I'm going to kind of work backwards, but let's just kind of go back and look at my circuit that I had there, right there. Here's my circuit. I'm going to call this R1, R2, R3, R4, R5, right there. And I can say this is going to be R1 plus R2, right there. Right there. So I can number these things. And this is going to go right there. Just remember my numbering that's there. This is V1, V2, V3, V4. Right there, and right there, and R1, R2, R3, R4, R5, okay? So I can write my script here and I can say R1 is equal to 10, R2 is equal to 20, R3 is equal to 6, R4 is equal to 8, R5 is equal to 8, right there. And I'm not so sure what's going on here. I normally put semicolons at the end. Right there. So, okay, right there. And then I can say V1 is equal to, what do we say, 20. V2 is equal to, what was it, 10. V3 is equal to, or, no, 12. And V4 is equal to 50. Yeah, this is V1, 20, V2, 10, 12 right here. It's a little hard to see that one there. And then 15, right there. So, okay. So then I can turn right around and I can say R is equal to, and this is the hard way of doing it, by the way. This is the hard way, but it shows the students where it comes from. And I'm going to say R1 plus plus R2 space negative R2 space right there 0 semicolon, and then I'm going to do a dot dot dot. Just simply I can dot 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 just means next line right there. And the reason I got the next line is because I got the screen so crunch right there. And then the second row is going to be negative R2 space R2 plus R3 plus R4 space negative R4 R1 R2 R3 R4 dot dot dot, and then 0 space negative R4 space or negative R4 space R4 plus R5 close bracket right there, and we can put the semicolon in there if we want that there. I'm going to leave the semicolon off because I want to see what the matrix looks like that there. And then I can simply say B is equal to bracket right here, and we're going to say B1 semicolon V2 minus or V1 minus V2 right there semicolon B, and that's V1 there. Actually, it should be V1 minus V2 right there. And this should be V2 minus V3 right there. Right there. And at this point I can run this. And here it wants to know where I want to save it. Right there. Right there, and I inspected MatLab. Right, it gives me an error in line 17, column 15, line 17, and it's because I got and it doesn't like my dot dot dot, so the dot dot dots work fine in the command window. They don't seem to want to work there. Okay, that there. So hopefully that agrees with what I had earlier. I'm not going to go through and double check it there. And then I can turn right around and say I is equal to R raised to the minus 1 times B right there. So there's my first script right there. So, and again, right here, I could again run this right there, or I could close this right there, and I can just take matrix X. And what did I, oh, 3x3. Right there. Okay. It caught my it got my spelling right this time, right there. Right there. So again, I've saved it right there. You know, the whole thing is that this particular function is now saved, and I can run it indefinitely. But let's say I want to change this resistor. I put them all at the top, and I can change one value and just run it again, right there. Right there. So I can vary that there. So again, it's one of those things you wouldn't necessarily do this every time at there. If it's a one-time problem, but if you're going to be varying, for example, a resistor value for various values, or you've got a function that you want to change the load and run it multiple times, but you don't necessarily, that there, you just simply run it like there. Now I can suppress this by putting a semicolon at the end of these right here and run that there. And again, it just runs it right there without showing the intermediate variables right there. So again, I could also, I can show the I right there. But again, as I said, you want, I'm looking at this not as a program, but as a script right there. And as we showed earlier, I could write the script and then cut, copy, and paste it from the command window right there. So, right there. I see some of you are starting to follow through and try to do these right there. That's the whole idea, is I want you to try that there. I typed this, you won't remember it. So that's the, right there. Is that follow along when I start when I go into MATLAB and start doing something, just follow me into that there. I'll wait for you to finish up that there. Professor Wan says that we cover what we cover and what we don't cover. It's better to cover a little bit very well versus try to rush. Right there. Right there. Actually, I kind of prefer having a real keyboard, but I hate carrying it with me. So, anybody got any questions, or you got to work right there? You use this in some of your classes now, MATLAB, don't you currently, or not yet? Are you using MATLAB in any of your courses yet? Okay.
Can you see your screen again?
Oh, my script? Yeah. Right there, that's the whole script right there. Stand up for a few minutes. Get some blood flowing. Yeah.
What's the capital R?
Capital R is this is the matrix that I'm creating. This is the matrix. R is the name of the matrix. This is the first element. This is the second element. This is the third element. Right there. Right there. Because going back to my circuit, right there. Yeah. You see, this is R1. This is R2. So this is R1 plus R2. This is minus R2. That there. Loop 1 and loop 3 don't interact, so that's a 0 there. So shared between loop 1 and loop 2 is the 20.
Can you show the loop 1, loop 2, and loop 3?
Yeah, it's kind of shown here. This little arrow right here, loop 1, loop 2, loop 3. It's just, that was in my pedal stack.
There's no one big loop.
You don't need a big loop here. That there. The rules on Kirchhoff's voltage law means that you have to include every component, but not necessarily every loop. So you could write a fourth loop, but it would be a redundant loop. That there, you don't need it. That there. In which case, my rule of everything off being diagonal is going to be negative, will fall apart. Because loop 1 will go, this will be positive, that'll be positive, that'll be positive. That there. But I could write a fourth loop. There's no reason not to. And I could write loop 1, loop 2, and then loop 3, and not have loop 3 in there. So I can write my loops multiple ways. So, but does that explain where R comes from? That there? Because again, here are, I just add up the resistors here. And that's the hard way of doing it, but keep in mind that if this was a problem, a generic problem, and you're going to have the same drawing, same circuit there, and I'm thinking of a mechanical where some of these might be loads, where the loads are going to change, that you'd want anything that's going to change up here in the top. There's a variable right there where you can change it quickly in the script and rerun the script. But don't get the idea that you're writing programs for people to run interactive, where you say, please enter R1, please enter R2. You know, you run MatLab that way, but doing inner reaction is not really what it's meant for. It's meant for, it's right there. Right there. Now later on we'll hopefully have some time. Oh, it's almost 3 o'clock right there. Okay. When I get up to about an hour, I'm going to take a few minutes to reset the recording. Yeah, you know, once these recordings get up to like an hour and a half, they take forever to encode. I like to keep them to an hour. Right there. You know what I'm going to do? Oh, reason, okay. All right. Okay, again, we've already done this, so the next few slides I'm going to kind of skip through here. This is, you know, how to open the command window at there. Script files can begin with any letter, include digits, underscore, up to 31 characters at there. Typically, I would say this program is like a number of programs. It doesn't like spaces and files names at there. I mean, Windows allows spaces, but older versions of software that existed at there. And this was originally written in Unix. You know, MatLab was originally designed to be run as a Unix program, not a Windows program. So spaces and files names are not really a good idea. And you run into problems trying to use the CD in the command window with spaces in the names. That's why I always end up just using my computer, going through and doing a CD to the root and then traverse through in the windows right there. So, okay. Do not give a script file with the same name as a variable. That goes back to the fact that the order was the first thing it's going to do is look for a variable name right there. If it finds a variable, it doesn't look for the script file right there. That there. Do not give a script file the same name as a MATLAB function. We found that when we use sign, that sign did work right there. Using sign as a script name earlier, we found that it worked, even though Rule 3 says it's not supposed to work. And it's not supposed to work. That may be something with MATLAB 15. We've already discovered a couple of minor differences at there. Debugging. We just had an example of all kinds of debugging problems. I should have brought your file up here for debugging that there. But if you have an error, and let me just kind of show you what happens with an error. I'll use some of his examples here. Let's say we do my brace right there. And I was doing enough of that this morning, wasn't I? Right there. So if I save that, go back to my command window, right there, and I run this, I get unbalanced or expected parentheses or bracket on line 17. Now, this is actually a fairly friendly error message to me. This is, having done computer programming back in Fortran on punch cards, that there, I would have loved to have this kind of error message right there. But it tells me on 17, this is unexpected parentheses or bracket right there. So I go back here to, where's my editor? Right there. Go back to my editor right here. And I find line 17. And sure enough, it tells me where the line is. It tells me looking for a unexpected break. Yeah, see, and this has got line numbers right there now, right there. So there's the line numbers right there. So it tells me where that is. That there, unbalanced or unexpected parenthesis or bracket right there. And this was what I was doing this morning. That's got to be a brace right there. Another common error might be I forget the 0 right there. I forget that 0. I come down here and it says error in line 17. This time it doesn't tell me. It says dimensions of being concatenated are not consistent right there. It just simply tells me that I'm trying to concatenate 1, 2, and then 2, 3, 1, 2, 3, 1, 2, 3. So the first row has got 2 elements, the second row's got 3, and the third row's got 3. So it's telling me that these rows are not consistent right there. That's what it's telling me that there. And these are typical of the type of errors that people forget right there. So, or end up with that there. So I think you had all of them on yours, right? That there. So I'm just picking on you that there. It doesn't matter, but again, these are consistent with the type of errors you're going to see when doing that there. Errors due to incorrect mathematical procedures or runtime errors, they occur at their common is division by 0. If you've got an error that's going to have a divide by 0, you're just going to runtime error. So that's just simply a logic error right there. Syntax errors are the most that they're. So if you got a logic error, then you're on. You got to go through and double check your logic and go through all the various steps. It's a long, drawn out process that they're. So program errors, test your program was simple. Check it by hand. This is again going through and that there. And this is kind of an important one right here, and my pen doesn't want to, right there. Right here is that if you remove the semicolon at the end of these lines, you can see the intermediate steps that there. And there. And again, you want to do a simple program right there. Now, as I said, I'm going to make this particular problem much more complex because I'm going to add in some inductors that there, right there. So, that there. So, okay, programming style, again, I'm going to go through this. The comments, it should have the name of the program, any keywords in the first line that there, the date, the creator's names, any variables that there, and the name of any user-defined function called by the program. We have not wrote any functions yet. We will be writing functions. Well, I was hoping to get to them today, but we may not get to them today.
The one that we just made?
That's just an M file. That's not a function. That there is that there. So programming style that they're calculating that there again. Input commands that they're right there. This is really getting into input and output commands. This is display and X is equal to input text right there. We can go through here and here it displays the text and quotes and waits for user input. I don't use this very much, but we could, for example, we could write a script file where you'll enter the load and then the person would enter the load if you had one variable that would change, for example, right there. So, at their example, this is one here. I'm going to just kind of leave this one at there. This probably will take probably 20 minutes there for you to solve that there. But you've got an object. This is from the mechanical. This actually came from the book here. It is from the book, right? That there's a mechanical problem out there. But we're going to drop an object there, and we're going to plot it right there. And here's the script file that there, and enter the final time in seconds, and this calculates right there. So I'm just going to leave this go for right there. But this is, you've got the speed of an object with no initial velocity, and we're going to plot v as a function of time right there, where t is the final time entered by the user right there. And the only thing that's a little bit different right here is that g, of course, is a constant right there. G is defined by 9.8 meters per second squared. That's the constant of velocity. Here is where we're going to get the final time right there. TF is equal to input. Now this will open up in the command window and ask you to enter the time right there. And it will store that value in TF right there. So that's an input command right there. I don't necessarily use the input command very often because typically I'm just solving problems right there, and I'm teaching students how to just use MATLAB to solve homework problems, but this author thought it'd be fun to do that there. So, right there. And then we calculate the delta time, that's the time between samples. So we're going to do 501 points right there. So that there. And later on, there's a function that actually is better for this. It's called lin space. That there, I prefer for this would be lin space. But this actually will calculate t between 0 and tf and give you 500 points for in between right there, plus 0. Calculate the speed values, g times t, and then show the graph right there. So this is the entire, and by the way, it probably will puke on that capital P. Right there. I just realized that he wrote this in a text editor and it capitalized the P. He probably cut and pasted it into that there. But I'll leave you go at this here. I want you to kind of go through this one here as well. Right there. So I think you should have the slides there. Not tell me when to. Don't worry about the comment section right there. These are the 2 pages you need right there. Yep. Oh, it's also in the book, pages 37, 38. Right there. Yeah. So I'm going to let you do that there. I'm going to sit back, relax, and in a few minutes, I'll probably have to come around and answer questions. And I am not going to. A bunch of 18, 19-year-olds who've got their cell phones handy, Facebooking during class. Right there. Okay. The next section of the slides, I'm just going to kind of fly by at there. There are, this just simply says that throughout the chapter they talk about there's key terms are introduced. That there, this is just basically on how to use the book. That there, so you should have a copy of the book, or if not, get a copy of the book. I'll make sure Professor Wong has a copy of all the slides and PowerPoints. That there, he can get a copy to you as well, and that there, and just kind of spread them out. That there, again, the note on the book is that don't put it out on the internet for everybody, but that there, at least I'll put my name on it. That there, there's a funny story about, and it was a true story. At my university, back when I was a lab tech as a student working there part-time, bought a copy of WordStar, an old DOS-based program that there, and it came on floppy disk, and I installed it on the first computer and ran it, and I put my name on the install without realizing that the software wrote my name onto the distribution disk right there. I didn't think anything about it. About 2-3 years, about a year and a half, 2 years later, I went to work at Magnavox, and I said, well, I need a copy of a text editor for writing my source code. Oh, here, we got WordStar, and they handed me a copy, the disk with WordStar on it, and when I installed it, it was my name. So evidently the version of WordStar that I installed for the computer ended up over at Magnavox being distributed among all the engineers with my name on it. That there, and if the company ever audited that there, they'd come looking for me. So I got a little paranoid there on a. The rule was that you made a copy of the distribution disk before you did the initial install, and you never made that there. So okay, they talk about the help at there. Again, this is all in the search tab. That there is the main thing when we look at MATLAB is that they do have some tabs up here. The home tab. This is the plotting tab. Again, you could actually do plots using this particular one right there. I've never used that tab right there, but you could actually do it at there. But again, if you go here, and this shows how to plot multiple, it gives you some examples right here. Right there, area plot, pie charts, right there. This is kind of some apps. We'll come into the apps here. But for example, if you want to do curve fitting, right there, this will actually fit curves. Right there, this requires the toolbox for that there. Optimization to optimize the programs. I'm definitely not going to get into that. Tuners for, this is PID controllers right there. These right there. This is the most common one that there. This is our new document, open document, save document. This is the one we normally will keep as far as our tabs that there. This is our section, publish, bold. This is getting into whether we want to get into display. If we want to copy and paste into Word documents, this is our publishing it there. And this is our view for manipulating that there. Again, I don't worry too much about this. If you look at the home and the edit, they're pretty much the same type of that there. So we do have the simulate library. I'm just going to click on that real quick. That's we'll spend a little bit more time. This actually, and it's taking forever. I've never hit it since I've installed this there. Hopefully it's not locking up. I have not run. But Simulink is another software package that comes with MatLab, and you normally requires toolboxes out there. So as we look at this right here, this is the Simulink library, and I could say the DSP toolbox right there. If I want to do a filter right there, I can do a filter design right there. I can specify I want a high pass filter right there. And this should give me here design a filter right there. And this gives me all the parameters. And for whatever reason, it's not letting me work with it. Right there, okay. And maybe I don't have this toolbox enabled right there. Right there. So, discrete FIR filter. Oh, yeah, I have not installed the toolboxes on this computer, so right there. But just kind of give you a view for it that there. We've got the aerospace right there, aerodynamics, if we want to look at the various right there. And these are all the parameters right there. So, right there, if we want to look at, again, a lot of this right here, that there's state flow, and right here, and here we can draw states right there, type thing right there, do a state transition. This is not really applicable. Most of these toolboxes aren't really applicable to mechanical problems out there. If you look at most of these right there, you will see that a lot of these are electrical discrete. The aerospace has a few mass estimated center of gravity right there. But these are basically, they're in. We'll come back. Let me look at these toolboxes this evening and make sure because I'm not seeing what we've got here, variable. Because apps is where I see most things that I've worked with right there. Yeah, so as we look at our apps, we've got signal analysis, control system. These are all various toolboxes that they're, but again, I'm not going to see a lot that's going to trigger that. Okay, get back to our slides that there, and that there. Okay, the help browser again, that just simply, this shows the help browser. And it gives you there. I have not found the help terribly great, but it's better than nothing. It's built into it. You'll probably find better examples in the textbook or other books that there.
Okay.
What's that?
Octave has
it also has help as well. And I think let me look at Octave real quick. Do I have Octave still running? That there. Again, I don't see the home, actually the layout. And I'm not even seeing To be honest with you, I don't even see the help window here anymore. They may have taken the help window out right there because it wasn't very useful. Because again, you can go, if you got a question, the only thing that help did is if I did help plot, it actually gives me the same stuff right there. If you got a command you've got a question on, just type the word help. That's the easiest way of doing it right there. You know, so if I had a question on help log plot, right there, and log plot's up there, right there, but right there, and that's that one there. Yeah, semi-log X. Okay, these are the ones log right here, and this just tells you if you want to do a log plot. It's semi-log that there. So again, it gives you that there, and usually they have search documentation fields right there, reference page in the help browser. Here's our help browser right there. And that just gives you that there. And this is actually the contents a little bit more. The help is there now. What I was wanting to do is bring up the octave. And octave, if I do help plot, it gives me the same basic type of information right there. So again, there, and the help right there, again, there's the on-disk help and then the online disk right there. Again, the online disk basically is the documentation, and you can go through and find calling the function. Here's how you call a function right there. Right there. So the help is similar right there. The help is more developed in MATLAB, but you told me that they spent $500,000 Reagans to have MATLAB in this lab right there. And I'm saying, well, for free you could have got Octave. And so, you know, what did you get for the $500,000? You get, obviously it's a better program, and it's better developed out there. But for Octave, what we've done in it, or what we did, my old campus, we actually bought so many MATLAB licenses that we got cheap from that there, and then we put Octave in all the labs, so they can go to certain labs and run MATLAB, but every lab will run Octave. So what that's done is it kind of forced the students that need to run MATLAB into the MATLAB lab, and everybody else that's just doing introductory and low-level MATLAB stuff into the Octave lab. And because they're close enough, the students can go back and forth right there. So, right there. Okay. That there. So again, the help is there right there. Again, he talks about help function name right there. So okay, now we're moving away, and this is probably going to be our last topic today. I mean, we're getting close to 4 o'clock, and to be honest, my throat's giving out. You see, I'm hitting the water pretty heavily right there. So okay, we're getting into relational operators. And that should tell anybody who's had any programming experience that the next thing I'm going to be talking about is if-then-else statements, right there. This is a programming language to a degree. We can do programming with it, right there. We can write M files with your scripts, and these M files can take on the flavor of a program, right there. So we have relational operators, and they look almost identical to the C operational operators. MATLAB was written in C, so it keeps the same flavor, but it has less than or equal to, greater than, equal to, equal, and not equal. Those are the typical, and these are what the functions. The only difference is C uses the explanation mark, equal, right there, instead of the tilde sign right there. So everything else is exactly the same as C, right there. So again, we look at here now, notice one of the things we can do that you won't necessarily do is we can say Z is equal to X is less than Y. And this is a kind of a neat little toy I have not found a lot of useful use for it, but what this is telling me is I'm comparing this array to this array, right there. Element by element. I'm comparing 6 to 14, 3 to 2, and 9 to 9. And in doing that, x is less than y. Any place x is less than the corresponding value in y, I get a 1. Any place else, I get a 0 right there. Here, I do the same thing. X is greater than y, and again, the only place there. And not equal to, I get 1, 1, 0. Equal, equal, I get 1, 1, 0 right there.
So you put the answer there, z is equal to x.
Less than y.
But at the second.
So what we're saying, give me a second.
3 and 2 for x.
Okay, what we're saying here is x, and I'm going to make, these are different arrays right there. So x is 9, 5, 8 right there. Y is 3, 5, 12. And can I put a semicolon in there? Nope. You know what I'm going to do? Well, how do you... Oh, I'm forgetting the equal sign there. Yeah, okay, the first one would have worked if I would have had the equal sign. And as I was just saying, toward the end of my day, I tend to make these silly mistakes, which I think everybody does that, right? And I'm not drinking my normal 12 cups of coffee either. I want to sleep tonight. Okay, so what I'm doing is I'm comparing, and I'm going to put x transpose and y transpose there. Because what I'm wanting to do is I'm wanting to compare the 9 to the 3, the 5 to the 5, and the 12 to that there. So I put z is equal to x less than y right there. And what I get back from that there is I'm comparing 9 to 9. Well, 9 to 3. Well, 9 is less than 3, so I get a 0. You know, so it's false. You know, just look at the result of this is true or false. Not 1 or 0, but true or false. But since this doesn't print true or false, it's printing 0 and 1. So the only one which x is less than y is the 8 is less than 12. 5 and 5 are the same, so that's false. So that's why I get 0, 0, 1, is that I'm looking at the last one right there. Now, there are some applications that this is valuable for. I just, you know, toward the end of the day, I'm not thinking of any right off right there. But I have used this before. Now, the same thing is I can do z is greater than y. And now, in this particular case, I get 1, 1, 0, because the only one that is greater is the 9 is greater than the 3, 5 is equal, and the 8 is up there. And then I could do not equal right there, and I get that there, or I could do equal, equal right there. So all I'm doing is just comparing the two arrays, and I'm doing it element by element right there. Right there. So again, remember what we said, that this is for array manipulation, and there are some situations in linear algebra where you're looking for that there, and I can go through and I can look at this array and in my software make decisions based on that there. So again, this is the relational operators right there. Right there. So the find function, x is equal to at there, and find x, y is at there. The first and third elements are non-zero right there. So again, what we're looking for is we're looking for computes the array containing the indexes of non-zero. For example, the first and the third elements are not zero, is what it's telling me right there. Again, what we're saying here is x is equal to, and I'm going to put more than 3. Let's just put like 5 or 6 right there. 5, 2, 3, 0, 1, 2, 0 right there. So if I say find y is equal to find x right there, well, what we're seeing is that 1, 2, 3, 5, and 6 right there. This is 1, 2, 3. 4 is missing because 4 is a 0 right there. That's why 4 is missing down below. 5 is there, 6 is there, 7 is missing because 7 is a 0 right there. So this returns an array of the number that's the size of the non-zero elements in the first array, and it lists what elements are not 0 right there. So if I come back here and I put in 0 here and 0 here, right now I've only got 3 non-zero elements right there. So all it's doing is just looking for 0 or not 0 right there. That find x at there. Again, why will we use that? I can't give you an example off the top of my head, but it is a usable function because I have written some code where I've used it before. Where that there. But again, it goes through it that there and that there. So right there. So again, the first and third elements are non-zero. That's all it says there. That there. So note the difference between the first that there and the find right there. Again, values, how many that there, you got the length, the indexes, fine. I'm not going to worry about that. Those I've never used right there. Okay, this is what I wanted to kind of finish the day with right there. Yeah, there, 4 o'clock's a good time. 4:30 is a good time to end, especially when we didn't take an afternoon break. That there, so. We have if expressions command, else if expression commands, else commands right there. So this is the general if then else. Now the if then else doesn't make sense unless you're writing a script file right there. So the else and else if are maybe omitted and not required right there. Also notice that we have the end right there. So it's a typical type of that there. Again, it doesn't make sense unless we got some inputs or some things are happening. I have not used MATLAB a lot for a programming language, but I have used it for a few simple things that there. I typically, if I'm going to write a programming program, I'm going to use C. That there, it's just that there. But MATLAB's got some tools that for very simple programs that I want to do things, especially with complex numbers that there. So again, suppose you want to compute that there, and you've got 3 functions, and this is a good one right here. And we're just going to say greater than 9. We use one formula. Between 9 and 0, we use another formula. If it's less than 0, we want another formula. So I'm going to just go ahead and show how this is done, and I'm going to let you kind of finish up with this one right here. But again, what we're going to do, and I'm going to cheat again as I normally do and put that on one side and the other on here. And again, what the way that there is that we're going to first off we're going to do x. X is equal to input, right? Enter x right there. Right there. And there's something missing there. I forgot the input. TF is equal to input, colon, semicolon right there. Well, that looks right. Okay, now it's doing that there. So the relationship that we're looking at right here is that we're going to simply say if x is greater than 9, right there, greater than or equal to 9, we're going to say y is equal to 15 times the square root of 4 times x right there. Yeah, that's going to be square root of 4 times x right there. That's a typo on right here. This shows the square root of 4x, and they put the 4x there, so this is not the right command. You can't say 4x, it's got to be 4 times x right there. Plus 10 right there. Else if right there. X is greater than or equal to 0 right there. We've already determined if it's greater than or equal to 10 right there. So we just put that in there. And then y is equal to 10 times x plus 10. Else right there. Y is equal to 10 right there. End right there. Okay. There's our script right there. And we're going to save that. Let me bring that up there. Editor. Save. If else. Right there. And just run that there. Enter x. X is going to be 10. We calculate right there. Enter x. And now I'm going to put minus 2, and it should come back with 10 right there. If I put 5, it comes up with 60, and right there. So I'll leave that there, but you can see how the if-then-else structure works right there. And that's a factor of editing language. This is probably the simplest implementation of an if-else statement you're going to find right there. Notice no semicolons, no fancy, fancy parentheses. The syntax is actually fairly simple for this particular one right there. So this is an example right there. And I'll let you go ahead and enter it and make sure you see how it works right there. Again, if you want to test it, you can say y is equal to 15 times square root 4 times 12 plus 10 right there. And I get 113, right? So I can come back up here and if then else, and I can put 12 in, and I get the same answer. So it tells me that it's doing what it's supposed to be doing. So, right there. So again, that's the simplest one. That's a very simple one right there. Right there. So, again, there's a problem with this syntax is wrong. It's missing the time symbol there. And I can tell he's dozing off there. It's almost time to call it a day, isn't it? I see you struggling. Right there. There's no way you're going to keep people awake till 5 o'clock doing this kind of stuff. Actually, this kind of workshop telling was better taught over 3 days and 3 half days. Right there. So again, right there. And I'm going to quit at this point. I know you said 4:30, but Professor Juan,
Yep.
I think it's a good time to quit. I'm losing everybody out there. I don't know what your thoughts are. I've seen 3 people dozing off in the last 5 minutes. And I know I'm boring, but it's not. I'm not that boring. It's the afternoon. It's warm in here. That there.
Okay. We need to have a photo session.
Okay.
After this one. Now, because this is part of the HRTN requirement, so that we can claim money from the resident. So perhaps Prof. Hack can put up the front page.
Oh, the first slide?
The first slide. but I think we just go ahead like that.
I'll figure out where we're at tomorrow.
For the afternoon tea and coffee.
Now you don't have to put the time on the photo session, right? You don't have to hold up the time.
No.
I know these photo sessions are, you know, I make fun of these things, these photo, you know, these group photos. I go, what is it? Every meeting we have a group photo. Every meeting, what is this? People want to group photos. It's like there's not a photo session, the event didn't happen. And then finally, I think, what's her name, you know, the little girl from the Dean's office? Nurul. She says, no, we have to submit the pictures. And then it made sense that.
How important the photo session?
Yeah. Yeah, I said.
You always take photos.
That's there. Because, you know, something like this, we would never take a photo. I've never seen a photo session at a training. You know, might be pictures during the training that, you know, go into like a scrapbook or a newsletter or something, but not a group photo at the end.
Ladies in front. Speaker.
Speaker.
Facilitator.
There's
This is normal. We put the flowers in front.
Okay.
Okay.
Don't worry, I don't like. Just me and the girls in the front there.
Okay, one, two, three. Okay, done.
Oh, now you got to think one with you in it, because otherwise you didn't get it.
Okay, 1, 2, 3, go. Another one. Okay, we get one.
Okay. I'll give you a copy of that. Thank you that there.
Thank you.
So,
I hope the queen and next lady.
okay, yeah. Yeah, tomorrow, yeah, I've only gone through the first chapter and I sent you 4.
Yeah.
So tomorrow I gotta go very, very fast.
Yeah.
That's there. I'll finish this chapter in like 10 minutes tomorrow. Yeah, like you said, you know, just the basics is gonna chapter 1 and 2.
We can go on ourselves.
What did you think?
Is that good? I hope people feel like it's worth spending your time. Sometimes I know the training sessions, I feel like it's wasted. I'm hoping you're learning something. Anytime you got a formula, you easily do plots. So actually, today's part, you want to write the formulas down that you want to see plots of. Just give me the formulas tomorrow, and I can go through the example. So, you know, any plots or any formulas that they want to see plotted or something, just bring them tomorrow. We can do that as an example. I mean, because that's you send me, yeah. Maybe I kind of formula, especially chemistry, I have no concept of chemical.
You are under the iPhone.
Oh, yeah.
iPhone all, right?
Yeah.
Yeah.
from my trip home.